Welcome. Please excuse the couple of minutes of delay. There were a bit of technical difficulties that we need to make sure will not interfere with the event. But I'm excited for the third and last workshop of this series. We are going to have Lip Evian, who's going to have a really, really exciting workshop with a magnificent title of Scoping All the Yummy On-Chain Data. Hey, Lip, can you hear me?
Yep. Can you guys hear me?
Yes. Maybe have a little bit of an intro about yourself and what the workshop's going to be about before diving in.
Yep. I just want to say thanks to Yasan and the Encode team for this opportunity. The title of the talk is Slurping All the Yummy On-Chain Data. Um, I guess so a bit about my background, just a developer relations at Mantle, which is a layer 2 blockchain. Please do check them out. Mantle.xyz or Mantle.io works. Engineer at heart, so I really like tinkering with stuff. Hence, why I would like to slurp all the yummy on-chain data so I can kind of play around with it and do some analysis on it.
Amazing.
Um, yeah, am I good to kick off,
Yeah,
Yusan?
feel free.
Okay, riddle me this. You know, what's the most important thing in a dApp? The face that draws them in. This you must know. The alluring mask that puts on a show. It's what user sees as it still steals the glow. Does anyone know? Feel free to type it in the chat if anyone is here. Hello, hello. Or is it just me and you, Yasan? Well, I guess it's all right. It's front end developers. That's the most important thing in your dApp. Yes, everyone's ready to slurp. That's great. We can because that's like the front end on your dApp is the number one thing that the user sees. Like when they interact with your dApp, they don't really care about the contracts. They don't really care how cool, how gas optimized your contracts are. They don't really care how sophisticated your code is. When they see your dApp, the first thing they see is your front end. So, and you would like your front end to be fast and snappy. You would like your front end to be able to display data in a very consumable manner, and you would like your front end to display the consumable data very quickly. And I'm pretty sure like Google or whatever has shown that if your site loads a bit slowly, like users just get fed up and leave it. So it'll be a good time to optimize your front end so that you get more retaining users. So we'll take one example from Uniswap. This is I'm sure everyone's seen this UI from Uniswap. It's very classic these days. On the surface, it's very simple, but behind the scenes, there's actually a lot of things going on behind. There's actually a lot of things going on. So, for example, right here, we're getting the ETH balance of the user. We're getting like how much DAI we might be getting given X amount of ETH. We're getting the exchange rate of DAI to ETH. We're getting the gas amounts in US dollars terms on how much this swap is going to cost. So behind the scenes, there's a lot of things going on. Oh, you haven't missed much, Kingsley. Don't worry. We're just getting started on the motivations. But anyway, behind the scenes, there's a lot of things going on. Um, in a very naive and trivial example on how you can extract these data, because keep in mind here, we're getting the ETH balance, we're getting the DAI, you're getting out for given the amount of ETH, the gas amount that is going to cost you, and as well as the exchange rate. So we're getting a lot of data on chain. So a naive example on how you would get this is with this method. You would have, okay, the cursor in here is in here. That's great. You would get the ETH balance, you would get the DAI balance, and then you would query the Uniswap um, function to get the amount of DAI you might get out, and you might then query the gas used. This is incredibly inefficient because this is blocking. What I mean by that is that before I can get the DAI balance, I need to get the ETH balance. Before I get the DAI amount out, I need to get the DAI balance, and so on. So this whole process, if you have a slow internet, might take you upwards of like, I don't know, like 30 seconds potentially if you have a slow connection. So um, uh, And a lot of sharp users might notice that you can actually parallelize these queries because they're not dependent on any amount of data. So a naive approach is to kind of just wrap them in a promise.all, which then executes all the queries in parallel. But the problem here is that we are executing 3 separate queries. We're executing signer.getBalance, which returns me the ETH balance. We're getting DAI.getBalance. We're getting Uniswap.get amounts out. Even though we are parallelizing this into 3 separate queries, we're still using 3 separate queries. This talk today is here to convince you that we can get this any amount of queries you need to perform in your front end down to 1. And I'm not kidding when I say 1. I mean just 1 query to get any amounts of data you need on your front end. And before proceeding, I would like to kind of talk about these functionalities where these little hacks where you can actually query mutable functions statelessly. For an example of this would be the total borrows current. This is from Compound Finance, which is technically a mutable function. So if you go to Etherscan and you look up this function on Etherscan, it would be under the write section instead of the read section. But you can actually use ETH call. You can actually call this thing statically in a read-only method, like this on ethers.js, where you call seed token.call static.total borrows current, which doesn't use gas because this means that you're calling it in a static way instead of calling it total borrows current as total borrows current. So if you do it at the bottom section like this, you're actually sending a transaction out, which then uses gas, and you don't actually get the return data because what you're getting there is the transaction receipt. You're actually sending a transaction. But if you do ctoken.call static or total borrows current, what you're getting you're getting the data back because you're calling it like a read-only function. So this is something I would like to point out beforehand, that you can perform a read-only on a write function. And this is what it's doing behind the scenes. It's actually doing an ETH call with the payload instead of ETH _ send raw transaction behind the scenes. So going back to the original journey, original motive, whatever you want to call it, can we do all of this in 1 query? My answer to that is yes, we can. Well, wish and you shall receive. MakerDAO, I think these days it's called Multi-Call 3 now, so this slide's a bit outdated, so please do check it out. Please do check out Multi-Call 3 instead of Multi-Call 2. It has a ton more features, but they're backwards compatible, so whatever I mentioned on this slide should work for Multi-Call 3. But anyway, MakerDAO has this contract called Multi-Call, which allows you to aggregate calls, multiple calls into 1 call. And it returns back the data in a very specific format. So in this example, we have a call structure where we call an address and we provide some kind of bytes. And then we get back some result, which determines if it's success, and the return data encoded in bytes. So there's this function called try aggregate, and then we supply it require success. Basically means that if 1 function in it fails and you specify true here, this whole function will fail. And usually I just say false here so that I can just skip over everything, even if it fails, and then I can just decode it on the front end. I got a couple questions here. Multi-call is great. Yes, it is great. Is the call static in the same category like other gas optimization variable like constant and immutable? No, call static is a ethers.js specific thing, which then going back here just does ETH call behind the scenes. It's not Solidity specific or EVM specific. Jumping around, I know, but basically multi-call aggregates a bunch of calls and returns you a bunch of results. The downside to that is that you have to kind of encode and decode a bunch of data, but now you can query a bunch of data in one query. So in the example before, we had 3 parallel queries, but now we have one query. The amount of data is slightly bigger, but it's just like kilobytes. We're not talking megabytes, we're talking kilobytes. So this is not really we can just ignore it because these days, you load your fancy JS frameworks that like a couple gigabytes, some whatever megabytes. So these are kilobytes. These are peanuts. But now we can query the ETH balance, the DAI balance, and the amount of DAI that we'll get out in one singular query. The downside from using MakerDAO's multi-call is that we have to encode a lot of these data in the right format, and it's a ton of hassle to encode and decode them. So, downsides. It makes things a little bit more complicated, but we can only query stateless things and stateless things. When I say stateless things, I mean stuff where there's no dependency on each other. And I'll elaborate a bit more on that in the later slides, as well as the multi-call contract needs to be deployed because we are calling a contract on chain to get our data back, right? Or do we? Can you get a presentation link or PDF? I will put the link up at the end. All right, Schlurp. Technically we don't, but let's dive a little bit deeper onto the ETH call payload structure. When we call DAI.balance of user address, what is happening behind the scenes is that we're actually doing an ETH call RPC payload to the provider with some encoded data with a JSON blob. And I think, this slide will kind of quantify it, will kind of elaborate on it. So when you call DAI.balance off, this is just ethers.js's way of saying, hey, this is a nice API. We'll provide you some kind of abstraction so we can handle it nicely. But what it's doing behind the scenes is that it's doing an RPC ETH call, and it's providing it with a array of data where the first parameter is a JSON blob. So for example, to the DAI address, and then we'll provide it some data, the data of which is DAI.encode function data is the encoded function of balance of and user address. Latest will be the latest block tag. But if you check out the Geth documentation, notice how we specified two things. The transaction call object, which is this blob over here, to and data. That's the transaction call object. And then we provided an additional parameters, which is quantity or tag, so block number, order string, latest or pending, and we provided latest. It actually accepts a third object, which is a optional object, which we haven't provided here. Hope everyone's following along. But you can actually provide this thing called the state override set. So you can override certain states when you're calling ETH call. Wow. What can you override in a state? Ooh, sounds very fancy. Turns out you can override a lot of things. You can override the balance in your ETH call. You can override the nonce. You can override the code, fake EVM bytecode to inject into the account before executing the call. Wow, sounds very good. State and state diff. State and state diff are all both very useful things, especially when you're doing some kind of on-chain calculation. On-chain calculations in regards to fancy math that you do not want to re-implement in JavaScript or Python or whatever language you're doing. One example is curves, curves liquidity thing, which I could never be bothered re-implementing. So anyway, it's very useful if given the right occasion. But every occasion is a nail and every tool is a hammer. So yes, this is a great tool in every occasion. Anyway, we can override the code in the account. Wow, that is fantastic. So now, instead of requiring our multi-call contract to be deployed, we can just provide it this additional parameter state overrides where we say, hey, at this address, we would like this piece of code to exist. And then now we don't need multi-call to be deployed before we can use it. Well, that's cool. But now we can query data in parallel without deploying the contracts. But now we can only query stateless data. Okay. When I say stateless data, I meant that data that is not dependent to one another. One example would be the ENS address query, ENS resolver, where I need to get so for example, to get the ENS name of my address, I first need to encode my address into this bytes32 format, and I need to call ens.resolver on my bytes32 to get a resolver, and then I need to pass the resolver and then call resolver.name on my node. So notice how there's dependencies here. So I need resolver from my node, and I need to pass in my node into the resolver before I can get back my ENS name. This is called stateful queries, where there is some dependency between your data querying. And so multi-call, unfortunately, doesn't help with that. So we still need two queries, yes. So we're using the resolver from part 2 and part 3. So this is a stateful example. So there's two ways to solve this, both with their own trade-offs, and I'll go in with the easiest solution, which is we write a custom contract and we set the code in. Yes, correct, Jordan. You can run the EVM code that you said. Yes, this is solution 1. You can just inject. You can write a custom contract and you can just inject the code in your state overrides. That's very that's nice. That's nice, but unfortunately, unless you're running your own provider, by default, this feature is disabled on a lot of the free RPCs. And as a RPC URL purist, I would like my code to work on any platform, on any MetaMask provider, or any provider. I think it doesn't work on some. You could run it on a local node, that's correct. But let's say I have a dApp, which other people interact with it. They might not have a local node, so that might not be an option when you're trying to slurp data. So there's also another solution, which is to write some assembly magic to force the constructor to return some data. In fact, you can ignore this whole chunk. The only thing that is of use would be this section here, the assembly section here, which is basically forcing the constructor to return a value. Now, by default, a lot of Solidity contracts, by default, contracts don't return a value, because why do you need to return a value in create, right? Like you just get an address and then you can interact with that address. Why do you need to return values? Well, you see, let's go back a few slides. Notice how we can query mutable functions statelessly. We can query this write function with .call static, but we know that when we do it behind the scenes, .call static actually does an ETH call instead of an ETH raw transaction. So what happens if we deploy a contract with ETH call instead of ETH send transaction? Wow. We just deploy a contract with its payload, and we do an ETH call, and we get back the data. Now, I know this sounds a bit abstract, because usually in live presentations, I would do a demo. And, okay, great. We can go to ETH call abuser, and we can check it out. Let me zoom in a little bit more. I have this repository called ETH call abuser. If anyone wants to check it out, we can check out some real life examples, which we can go to script TS. We can check out the ENS example. So, for example, here we have a contract called free ENS. And in this FreeNS, it's basically, we provided a list of addresses in our constructor, and then it basically resolves it and codes it in the right format, and it returns our data inside the constructor. And if we go back here, we basically query, we get the deploy transaction of the FreeENS factory. So someone saying, please explain, I don't understand, why can't you just deploy an actual contract that queries? It's only deployed once. You can, I just don't want to spend $300 to deploy a contract. That's it. You definitely can. This is just so it's more agile and nimble. Yep. It's terrible for mainnet, by the way, because you're basically overloading a bunch of free RPC URLs, but it works for your use case, so it's great. So all I do here is I get the deploy transaction. I do provider.call, which is Eve call behind the scenes. I get back my data, and then I just re-encode it because it's in a string format, and that's it. So by TLDR, by forcing the constructor to return a value, I can abuse it by pseudo deploying the contract with the Eve call function and get back any kinds of data I want. So basically, I write the logic in my contract. I fake deploy it and get the data back. And boom, we have all the data we need for our front end. So you could, instead of ENS here, it could be like, all right, get user address, get your DAI balance, get your ETH balance, get your health factors, get XY, and then get all the data you need, and then return it in some kind of tuple or something. So you just have to query it once. And yeah, anyway, there's trade-off, solution one, state overrides. It has superior data batching query capabilities because the contract, you're basically overriding the code, you're injecting fake code, but it does not work with like all providers. Solution two, which is the constructor overload, is very nimble and agile, works on all providers, but it easily hits the bytecode size limit. What if they disallow function object native code to return a value in the future? That is a problem from the future, I suppose, but I don't really think they're gonna change the EVM that significantly. I think they're talking about removing the self-destruct for like 3 years and haven't done that. So I think we have enough time to prepare for that if that happens. Yes. But yeah, that's my talk. Thanks for listening to me ranting about how you can slurp all the data. If you would like to check out the repositories, it's on GitHub, Eve Call Abuser, or if you want to check out like the Geth examples on how you can do the stateful overrides, you can also check out Geth examples where you can check out how to override state. For example, ERC20 allowance. Any questions? Happy to answer them.
Yeah, there are a couple of questions in chat. Jordan's asking.
Oh yes, cool hack. And I think disallow function object native code. I think for now it's fine. I think they again, I think I mentioned this, but they've been talking about removing self-destruct for a while, and if they haven't even removed self-destruct, I think this is probably not going to happen in the near future.
Right. Any other questions? And they should not only be for the workshop as well. Like if you have any questions regarding the hackathon itself, or something that might be troubling you, questions on how to properly hack and submit, feel free to share. I see a couple of you typing, so yeah.
Oh, thanks for listening. Yes. No, it's not too late. I think it's still.
We're still in the midst of like week 2, still workshop week, but that was the last workshop in the series that we've planned. So you are free to hack on, and you have like 2.5 more weeks until the submission deadline. So more than enough time for you to hack, or find teammates in that if you need some. Great. Looks like no more questions. One last one.
When injecting custom contract code, do you need to point to any on-chain address? No, you do not, because you are injecting custom contract code. Oh, yes, you need to specify it. Here, maybe this will be a bit more concrete. If you're injecting code, like, yes, you have to point it. Like, basically, this can be address 123, like multi-core underscore ADDR can be address 123, and then you need to call it to address 123. So you need to point it when you're injecting it. Yes, you do need to specify like a address to override. You can even override like Aave's A token code if you want, but then that might break some things. But this case won't work for public nodes, correct? It might work for some public nodes, but it depends on the provider. So some providers they block them, some providers they don't. So this is dependent on your provider. Ah, you can check out my GitHub. It's github.com/libevm. Uh,
And also, if you do have technical questions for the duration of the hackathon, make sure to share them in the Discord, and we will make sure to forward them to Lib or any of the other developers that had the pleasure to speak in front of you. So yeah, hack away if you're still looking for ideas on what to build for the duration of the hackathon. And if you have questions, do feel free to reach out, and we'll help you. We'll help you to connect with everyone in the Mantle team, and hopefully submit something in the end.
Awesome. Thanks, Yusan, for hosting. I appreciate your time.
Absolutely. Likewise. Thank you all for tuning in, and see you around. Enjoy your days.